Since no piece of equipment runs forever, we inspect the boiler in our plants at least once a year to look for problems that might cause shutdowns or reduce the boiler's efficiency. There are two major areas that are inspected: the fire side and the water side. The fire side is the surfaces inside the boiler that are exposed to fire and hot gases. The water side is the inside surface of any boiler component that contains water or steam. Now, what we're going to be talking about here is how to detect potential problems during a routine fireside inspection. That means we'll be inspecting the surfaces inside the boiler that are exposed to fire and hot gases. Even though you're not the official boiler inspector, the work you do allows you to detect certain problems that can affect boiler reliability and efficiency, if you know what to look for. So, what we'll do now is to go through a typical fireside inspection and point out some of the things that you'll need to know. Several preparations must be made before inspecting a fireside. Before you begin, check with your boiler operator to make sure that bottom ash has been pulled and all soot blowers have been blown. Then, check to see that combustion deposits like ash and slag have been cleared from the boiler. You won't be able to get all of them, but the inside of the boiler should be as clean as possible. The boiler should be shut down and tagged out. Tagging out guarantees that none of the valves will be tampered with during inspection. Once the valves are tagged out, access and inspection doors should be opened to cool down the boiler. Immediately after shutdown, and while the boiler is still hot, go to every opening in the boiler and listen for leaks. If there's evidence of leaks, note the location. After you've listened for leaks, the boiler should be cooled down. Now, once these preparations are complete, the first fireside component you'll be looking at is the water walls. The water walls are made up of water-filled tubes that line the inside of the furnace. When the furnace is in operation, heat is transmitted through the tubes to the water, which is eventually converted to steam. Water walls have four common problems: overheating, support failure, ash accumulation, and refractory failure. Overheating in the water wall tubes leads to warping, leaks, and tube blisters. Warping is caused when a section of the water wall overheats. This is fairly easy to spot. It may be indicated by a large number of leaks in a small area of the water wall. Now, tube blisters, like these right here, are bulges in the tube surface, which form when the tube metal becomes so hot that it softens and is pushed out by the boiler pressure. Now, the next problem, support failure, shows up in the water walls as vertical misalignment of its tubes. Water walls are attached to headers that are usually hung from the top of the boiler. Now, if the supports holding up a section of the wall break, that section will sag. And if that happens, you'll see a section of tubes that is lower than the others. It's important to check this out because support failure could lead to the collapse of the entire boiler. Now, the third problem affecting water walls is excessive ash accumulation. This can be plainly seen by looking at the water walls. There are two kinds of ash accumulation to look for: ash that adheres to the entire water wall and clinkers that are fused to it. Now, clinkers are dangerous since they are large and they can hurt someone if they fall. Be sure to clean them away before working inside the boiler. Now, another problem we need to discuss is refractory failure. This is a piece of refractory right here. It acts as insulation in the boiler. Refractory failure usually occurs wherever refractory is exposed on the inside of the water wall. Typical areas where you can see refractory are the burner openings, the ash hopper area, inspection doors, and air inlets. And what you should look for are things like general deterioration, or cracks, or water damage. Refractory has other potential problems: spalling, cracking, and slag attack. Spalling is the flaking away of refractory. It's caused by improper installation of refractory, by sudden temperature changes, or both. Cracking is due to improper installation or sudden temperature changes. Slag attack is the chemical reaction of ash and refractory. Slag attack erodes refractory, reducing its thickness. It melts the refractory and causes it to run off. Slag attack may also cause refractory to become soft and crumbly. In some cases, slag attack will produce a glassy surface. Refractory failure, overheating, support failure, and excessive ash accumulation are not the only things to look for during a fireside boiler inspection. There are also metal problems, such as surface deterioration, failure of previously repaired areas, failure of construction welds, and leaks. Surface deterioration, like water wall erosion, can be caused by steam or water, fuel, combustion gases, or soot-blowing air or steam. Erosion can cause tube thinning. Tube thinning is a serious concern because the thickness of tube metal provides strength to contain boiler pressure. Now, these tube sections were cut out of a water wall. You can see how much thinner this side is than this side. And when the thickness of a tube is reduced, the tube is weakened, and this can result in tube failure. All boiler tubes have an acceptable minimum wall thickness. When you inspect the tubes, you have to be aware of the amount of tube thinning that can be tolerated before repairs are necessary. Now, to some extent, tube thinning can be determined by looking at and feeling the tubes. You can tell that local thinning caused by erosion has occurred because you can see and feel a gouge in the affected tubes. Erosion can happen wherever there is any flow across a boiler component. Erosion from steam or water is caused by leaks in the water wall tubes. When a tube leaks, a stream of water or steam shoots out, and if it hits a nearby tube, this stream of water or steam will wear away some metal, possibly causing more leaks. Carefully inspect the area around leaks for evidence of tube erosion. Eroded areas, as well as the original leak, should be repaired to guard against future tube failure. Other problems besides erosion may crop up in the soot blowers. Soot blowers enter the water walls through openings that should be checked when inspecting the water wall. Look for damage to exposed refractory in and around the openings. Make sure the openings are clear of ash and slag. Also, check to make certain that all the soot blowers fully withdraw. Heat in the furnace can damage the soot blower lance. Erosion is still a major concern here. Check the tubes around the soot blower openings for erosion that may be caused by steam or air coming from the soot blowers. If you find any, the soot blower may be improperly aligned, that is, blowing against rather than across the tubes. Now, if that has happened, both the soot blower alignment and the erosion must be corrected. Corrosion is similar to erosion. Corrosion is the gradual wearing away of metal by chemical action. Rust is an example of corrosion and is most likely to occur when tube metal gets wet. Another example is corrosion from soot or ash. Soot or ash can be found anywhere in the boiler. Generally, though, corrosion occurs in out-of-the-way places. Corrosion caused by rust, soot, or ash is detectable because of its coloration, mostly red or green or yellow. Corrosion and erosion are only two problems that you might find on the outside of the water wall tubes. Other problems to watch for are pitting, cracking, and scale formation. Pitting is a type of corrosion and appears as small craters in the surface of the tube metal. In severe cases, pitting can weaken the tubes, eventually causing failure. Cracking can also result in tube failure. Any sized crack in the tube surface weakens the tube. Once a crack is formed, it tends to grow deeper. Over a period of time, the crack will penetrate the tube wall and cause a leak. Finally, scale on the outside of the tubes presents two problems. For one, scale like ash insulates the tube and prevents proper heat transfer. This reduces boiler efficiency. The second problem is that corrosion may occur beneath the scale where it can't be seen. Checking for all these problems does not end your inspection of the water wall. Old repairs must also be checked. Careful records should be kept of each repair, what it was and where it was located. During each inspection, previously repaired areas should be examined to make sure the repairs have not failed. A failure that happened in a particular area once may happen there again. Another water wall item to check out is construction welds. These joined the tubes together when the boiler was first built, and they're subject to leaks. Leaks in general are the fourth potential problem in the water wall tube metal. Since the boiler is shut down during inspection, water may not be spouting out of the leaks unless the boiler is under pressure. So, to detect leaks at the welds, look for dampness on the tubes or discolorations of the water wall. Any visible erosion or corrosion anywhere may be evidence of leaks. Also, any tube crack may be a leak. We've gone over 4 potential problems with the metal in the water wall tubes. Surface deterioration, including erosion, corrosion, pitting, cracking, and scale formation. Failure of previously repaired areas. Failure of construction welds. And leaks. Earlier, we covered preparations for a fireside inspection and many of the problems you must look for in the water walls. Let's pause for a few minutes so you can review all of this material before we continue.